Statistical data. Overview. Learning objectives. By the end of this unit, you will be able to explain the importance of statistical data in AI learning and decision-making. Identify real-world applications of statistical data across multiple sectors. Use no-code AI tools like Orange to explore, train, and evaluate models. Apply the steps of the AI project cycle to analyze datasets and solve problems. Understand basic data science processes such as data acquisition, analysis, and visualization. Statistical data in artificial intelligence. Statistical data is the foundation of artificial intelligence. Without data, AI systems cannot learn, make decisions, or solve problems. It helps build, train, and evaluate AI models so they can solve real-life problems accurately and efficiently. Statistical data is a collection of facts and figures that can be used to discover patterns, predict future outcomes, make better decisions. Role of statistical data in artificial intelligence. Statistical data is like the fuel for artificial intelligence. Just as a car needs petrol to run, AI needs lots of data to learn and make smart decisions. Training AI models. To solve problems or recognize patterns, AI systems need training, just like students learn from books and practice problems. How it works. AI is shown many examples. It studies this data to understand how things work and starts making predictions based on what it has learned. Example. A voice assistant like Alexa is trained using thousands of voice recordings so it can understand different accents and reply correctly. Learning from data. AI uses machine learning and deep learning to powerful methods that depend on statistics. These methods analyze huge amounts of data, find patterns and trends, classify information into groups, make decisions or predictions. Example. Netflix uses AI to learn your watching habits and suggest shows you might enjoy, all based on your previous data and behavior. Real-world applications of statistical data in AI. Healthcare. Disease diagnosis and prediction. AI studies patient symptoms and records to detect diseases early. Example. AI detects early signs of diabetes by analyzing blood sugar trends and lifestyle patterns in patient records. Public health monitoring. AI monitors health data to control outbreaks. Example. AI identified rising dengue cases in a city using hospital admission and mosquito breeding data, helping authorities spray pesticides in affected areas. Business and marketing. Market research. Companies study customer needs before launching a product. Example. A mobile company uses customer reviews to decide the features for its next smartphone model. Targeted advertising. AI shows ads to people who are likely to be interested. Example. You watched videos on guitar tutorials, and now you see ads for online music classes. That's AI-based personalized advertising. Education. Student performance analysis. Schools use data to identify learning gaps. Example. AI helps identify that most students in class 9 are weak in algebra, so teachers plan special revision sessions. Educational policy planning. Governments plan based on education trends. Example. Data showed low girl enrollment in science courses, so the government launched a scholarship program to promote STEM, education for girls. Sports. Player performance evaluation. AI helps coaches analyze each player's contribution. Example. In cricket, AI tracks how often a bowler gets wickets during power plays and helps select players for the T20 squad. Match outcome prediction. AI predicts game results based on historical data. Example. Before a World Cup hockey match, AI uses past performance and weather data to forecast the game result. Environment. Climate change tracking. AI monitors natural changes in the environment. Example. AI tracks the melting rate of Himalayan glaciers using satellite images and temperature data. Wildlife conservation. AI uses sensor data to protect animals and biodiversity. Example. AI monitors elephant movements through GPS collars to prevent them from entering farmlands, avoiding human-animal conflict. No-code and low-code artificial intelligence tools. As artificial intelligence grows, it's no longer just for experts or programmers. Today, no-code and low-code tools allow students, teachers, business people, and others to build artificial intelligence models without needing to write complex code. What is no-code artificial intelligence? No-code artificial intelligence platforms let you build artificial intelligence applications without writing code. These tools are visual and easy to use, allowing you to drag and drop components and use pre-trained artificial intelligence models. Key features of no-code artificial intelligence. UI-based tools. No-code artificial intelligence tools are designed for people who don't know programming. Example, a school teacher can easily build a student-grade prediction model by dragging and dropping blocks, just like arranging shapes in a puzzle. Ready-to-use models. These platforms come with ready-to-use artificial intelligence models that you can apply with a few simple settings. Example, a shop owner can use a pre-built model to guess which products might sell more next week just by uploading past sales data. Automation. Many tasks like cleaning data, choosing the best model, and testing it are done automatically by the tool. Example, a student uploads a dataset in Orange Data Mining, and the tool suggests the best model for prediction without the student needing to decide or code. No coding required. You don't need to write any code to use these tools. Everything is done through clicks, menus, and visual blocks. Example, a farmer uses a no-code tool to predict which crop will grow best in the coming season, using past weather data, all without writing a single line of code. No-code tools. Orange Data Mining. Drag-and-drop tool for data visualization and machine learning. Google Auto Machine Learning. Build custom artificial intelligence models for tasks like image or text recognition with no coding. Lobe. Upload images, label them, and create artificial intelligence models easily. Teachable machine. Create models for images, sounds, or poses using a web interface. Runway machine learning. Apply artificial intelligence to images and videos without any programming. What is low-code artificial intelligence? Low-code artificial intelligence platforms let you build artificial intelligence models with a small amount of coding. These platforms are great for users with basic tech skills who want more control and flexibility. Key features: pre-built artificial intelligence components. Provides ready-made artificial intelligence modules like image recognition, natural language processing, and data analysis that can be easily integrated. Automated model building. Automates many steps like data cleaning, feature engineering, and model selection to speed up the artificial intelligence development process. Customizability and flexibility. While most functions are drag and drop, users can customize models or workflows with simple code snippets for more control. Integration capabilities. Easily connects with other software, databases, and cloud services to import data and deploy artificial intelligence models. Faster development and deployment. Speeds up building, testing, and deploying artificial intelligence applications compared to traditional coding methods. Collaboration support. Enables teams including business users, data scientists, and developers to work together efficiently on artificial intelligence projects. Low-code tools. Microsoft Power Platform create apps with artificial intelligence features using mostly drag and drop but some scripting. IBM Watson Studio use drag and drop with some coding to build more advanced artificial intelligence models. Data Robot, mostly automated, but allows some code customizations for better model tuning. H2O.ai driverless artificial intelligence, automated artificial intelligence with options to add some code for customization. Differences between code and no-code artificial intelligence. Introduction to data science and applications. Data science is the study of data to extract useful insights. It includes collecting data, analyzing it, visualizing results, making decisions. Example: e-commerce platforms like Amazon use data science to suggest products based on your past searches and purchases. This is possible due to artificial intelligence tools analyzing statistical data. Orange data mining. Orange data mining is a free, open-source no-code artificial intelligence tool that allows visual programming, data analysis, machine learning, model evaluation. The artificial intelligence project cycle consists of structured steps to solve a real-world problem using artificial intelligence. In this case study, we use Orange data mining, a no-code tool, to explore and analyze the Palmer penguins dataset, which contains information about different penguin species. AI project cycle in Orange data mining. Case study: Palmer penguins. To understand how artificial intelligence works in real life, we follow a process called the Artificial Intelligence Project Cycle. In this example, we will use a tool called Orange Data Mining, which is a no-code artificial intelligence tool. It allows you to build artificial intelligence models without writing any code. The dataset we are using is called the Palmer Penguins dataset. This dataset contains details of different penguins found in Antarctica. It has information like the penguin species, the length of its flippers and bill, body weight, the island where it lives, and its gender. Example: imagine you are a wildlife scientist working in Antarctica. You are studying penguins and want to identify the species of a penguin just by looking at its size, flipper length, and body mass. You don't know coding, but using orange data mining, you can create an artificial intelligence model that learns from the data and predicts the species of a penguin automatically. Steps in the artificial intelligence project cycle in orange data mining. Problem scoping. This is the first step where we define the goal of our project. In this case, the problem is to predict the species of a penguin using its physical features like body mass and flipper length. Data acquisition. In this step, we get the required data. We download the Palmer Penguins dataset and upload it into the Orange software using the file widget. Data exploration. After loading the data, we need to understand what the data looks like. We check the values, identify if any data is missing, and visualize relationships using widgets like scatter plot and box plot. This helps us find patterns in the data. Modeling. Now that we understand the data, we train the machine to recognize the patterns. This is done using artificial intelligence models like logistic regression, random forest, or naive Bayes in Orange. These models learn from the penguin data to make future predictions. Evaluation. After training, we check how well our model performs. We use widgets like test and score and confusion matrix to see how accurate the model is and where it might be making mistakes. Step-by-step workflow in Orange. Drag the file widget and upload the Palmer Penguins CSV file. Connect it to data table, box plot, and scatter plot to explore. Add logistic regression and random forest widgets for modeling. Connect them to the test and score widget. Add the confusion matrix to understand detailed results.